What? What they are saying?
Sunday, they're saying that it's gonna be the last day.
Sunday is going to be the last day. So syllabus isn't complete till now.
No, syllabus is still done. Like 1-2 days ago, sub over for all these
Okay.
subjects.
Okay.
Till what we say, till Sunday we can keep night, and then uske baad the rest you can keep mornings.
Okay, fine.
And also, sir, for this
Mm-hmm.
exam, this chemistry exam, which is like coming right now, they said
Mm-hmm.
that they won't put the last 3 chapters. That
They
is
would
aldehydes, amines, and one more.
and biomolecules. Okay,
Yeah.
fine. So coordination compound is coming. So I think we should start with coordination compounds, right?
Yes, coordination. Even biomolecule is coming. For us, the
So what is
last different chemical kinetics, electrochemistry, all this is coming. And I don't
no?
know.
What is so last three? What is not coming?
Let me check. I'll let you know by
Mm-hmm.
the end of this class.
Acha, fine, no problem.
And so can we finish like the DNF block, coordination compounds, and that all before like this chemistry exam?
That's what I was saying, na? Since coordination compound is the one of the major chapters that is coming, which you have not done till now. In the extra classes, I will teach you coordination compounds. Okay.
Okay, sir. So tomorrow morning you can put the class Fridays holidays.
Uh, Tomorrow morning. Okay, fine.
And even Saturday, like Friday, Saturday is holiday. So both mornings, if you want, I can.
Okay, Friday, Saturday is also holiday. Okay, that's good then. Okay. So 2:30. Mm, Tomorrow I can't, I think, because tomorrow I have another extra class with some students in the morning and the evening also. Saturday there can be something. I will tell you about Saturday, okay? And if I don't tell you about Saturday till tomorrow evening, then just message me, okay, Asta?
Yes, sir.
So in the last class, we were talking about molar conductance and conductivity, these things, and we ended up with one term, which is infinite dilution. Infinite dilution means we have diluted the solution so much that I mean, the conductance or the molar conductance, it is not going to increase anymore if we dilute further. Okay, if we dilute further, then the molar conductivity is not going to increase. Right, next, write a note. When solution is diluted, number of ions per unit volume decreases. Hence, conductivity that is kappa of solution. बताइए क्या होगा? Kappa of solution will be what? When solution is diluted, number of ions per unit volume, it decreases, and that is why if we have less number of ions per unit volume, that means there will be less conductivity also. So the solution decreases. Okay, so very important thing regarding the effect of dilution on conductivity and molar conductivity. Both of these are completely different. So please see effect of dilution. We take the case of conductivity kappa, then kappa is directly proportional to the concentration. And we can also say that kappa is inversely proportional to dilution. But in the case of molar conductivity, it is inversely proportional to concentration, and molar conductivity is directly proportional to concentration. Oops, sorry, directly proportional to dilution, not concentration. Let me know once you're done writing this.
So what's the symbol for conductivity?
What was the
What is the symbol for conductivity?
conductivity? It is kappa.
Kappa.
It is kappa. Then everyone, yes or no, please tell me.
Done, sir.
No, right. Effect of dilution. On lambda m of weak electrolyte and strong electrolyte. Okay, so there is, what is the difference between weak electrolyte and strong electrolyte? Tell me, guys. What is the difference between weak electrolyte and strong electrolyte? Yes, Asta, tell me.
In strong electrolyte, there's complete dissociation of ions, and in weak electrolyte, it's not complete.
So in weak electrolyte, how can we increase the dissociation? Is there any way of increasing the dissociation?
More dilution.
More dilution, right? And whenever we do dilution, the dissociation is going to increase, right? It is going to increase whether it is weak or it is strong. In both the cases, the dissociation is going to increase, but the increase in dissociation will be very high for the weak electrolyte when we dilute it, because it is partially dissociated. Strong electrolytes, these are almost completely dissociated. Okay, these are almost completely dissociated. That is why if we are going to dilute it furthermore, they are going to dissociate more, but that increase in dissociation will be not as high as that of weak. Okay, so weak electrolyte in when I am going to dilute it, it is going to dissociate more rapidly. First of all, let's see for strong electrolyte. Please write when solution is diluted, molar conductivity of strong electrolyte increases slowly, because dissociation is also increasing slowly, because strong electrolyte is rather are almost completely dissociated due to which graph of lambda m versus root c is linear.
Sir, can you show the heading again?
Just a second. So here we are going to plot root c, and here we are going to plot the molar conductivity. Okay, and generally we have a habit of seeing the graph in this way, but for this particular graph, what we are doing, we are increasing the dilution, and when we increase the dilution, the concentration is going to decrease. Concentration decreasing, that means you have to see the graph in this way. Okay, concentration is decreasing and we are increasing the dilution. So the graph will be something like this. As we increase the dilution, the concentration becomes low and the molar conductivity slowly increases, linearly increases. Okay, get this blue color. Yeah. Now, and we can further extrapolate this graph. Rather, I should have made the full graph only. Okay, and this point, it denotes the molar conductivity when the concentration is 0 or the dilution is infinite. So this represent molar conductance at infinite dilution, lambda naught m, or we also say this lambda infinity m. Okay, this is the molar conductance at infinite dilution or the molar conductance at 0 concentration. One thing that is pretty much clear from this graph is that we can determine lambda naught m for an electrolyte. Oh, sorry, for a strong electrolyte, using this graph. Let's start with concentration, some concentration here, and end up with some concentration here. We will get a plot like this, and then we can further extrapolate this in order to get the lambda naught m. This is theoretically important. You will not be asked to calculate the lambda naught m from the graph, but theoretically it is important because of the next Yes, that is weak electrolyte. All of you wrote this? Yes or no? Please tell me. Write this down. Let me know once you're done. Done, guys. Can I move on?
Yes.
Yes. Okay. Right, B part, that is weak electrolyte. What was I writing? A, B, 1, 2. Achha, also, right, wait a second. Right, next, this graph follows. Please write with me. Graph follows Debye-Heckel. Debye-Heckel equation. It says that lambda m at a particular concentration will be equal to lambda naught m minus b into root c. Okay, so what is this? This is your y. Okay, and what is lambda naught m? This is your c. Minus b is your m, that is the slope, and c is your x-axis. So this graph follows slope-intercept form. Right, next, the constant b depends on the charge on ions and the temperature. We write next, weak electrolytes. when solution containing weak electrolyte is diluted, then lambda m increases very sharply because weak electrolyte is only partially dissociated, and as the dilution increases, the dissociation of electrolytes also increases.
So what is in the second line is diluted then?
Lambda m
Okay.
also increases, and hence the graph between रिवाइज करके नहीं आए हैं आप मोहम्मद उमर? मोहम्मद उमर,
What, sir?
did you not revise?
Sir, I was not there in previous class. I was absent in the previous class.
असल में you were on a different batch last time ना, इस वजह से आपको ही मैसेज चला गया होगा maybe.
Yes, sir. I was a bit confused. I was not going to join today's class as well. But then I saw my messages and then I came to realize that I have to join.
Yeah. And I think, yeah, I have not changed the batch name in your contact number. I think a few more students must have got this. No problem. Okay. Now, again, this graph is also, you have to look at from right to left and not left to right. Okay, so the graph between lambda m and root c will look something like this. That means when we are increasing the dilution, that means the concentration is becoming low, the lambda m is increasing very rapidly. The lambda m is increasing very rapidly. And from this graph, it is very evident, please write a note. It is evident that lambda naught m, that means the molar conductivity or molar conductance at infinite dilution of weak electrolyte cannot be determined by above graph. Because as you can see, when the concentration is approaching 0, this is approaching infinity. So we cannot really determine what is the lambda naught m of weak electrolyte. And for this, we have the Kohlrausch law of independent migration. The law of independent migration, it helps us in determining the lambda naught m, or the molar conductance at infinite dilution for weak electrolytes. Okay, one of its application is this. So write this down fast. Let me know once you're done, and we'll write the next topic, Kohlrausch law of independent migration. Astha, aldehyde, ketones, and carboxylic acid is not coming in your recent test, right? The next test.
Yes, sir. Sir, I checked only 2 chapters are removed. That is aldehydes and amines. The organic.
Okay. What about others? Tell me, Khalid, Nabil Ahmed, Nabil Khan, Khalil Minashi. Should I start aldehyde and ketones?
Yes, sir.
Aldehyde and ketones. Okay. So I think Asa, this would work for you also, because we can do coordination compounds in the extra classes, and aldehyde and ketones you can do in your regular classes, right, Asta?
Yes, sir.
Okay. And if anyone else wants to join these extra classes, please let me know on WhatsApp, okay? So that you will also get the links for those classes. And these classes will be not on the lecture hours, obviously. It will be either in the morning. And when I say morning, it will be somewhere around 8 a.m. KSA time, okay? And if it is in the evening, it will be 11 o'clock in India will be how much? 11 o'clock in India will be how much in Saudi Arabia? 11 minus 2 is 9.
9:30.
It will be 8:30. 9:30 or 8:30?
9:30.
8:30.
8:30, na? 8:30. 8:30 p.m. KSA. I think your classes is from 6 to 8, right? So you can get half an hour time, and then my extra class can begin if you want to join, okay? And please let me know. These are the 2 timings for the extra classes. And if you have your exams on December, no, then just please tell me, okay? Please tell me. I will have the extra classes.
So I
Yes,
have
Nabil Khan.
exams from December 12th. And
December 12th.
aldehydes are coming, yeah. Aldehydes are coming.
Aldehyde is coming.
Yeah.
So aldehyde I will be starting here, right? Same for Muhammad Umar also. Okay.
Yeah.
Fine. Like the whole is completed. Syllabus is completed
Yes, sir.
in your school.
It is
Okay.
about
Nabil Ahmed. Okay. Nabil Khan, what about you?
No, sir, it's still going on.
It's still going. ओके तो प्लीज देखिए अभी आप लोगों ने नाम तो बता दिया अपना लेकिन हमको मैसेज कीजिए आप लोग ठीक है ना नबील अहमद एंड मोहम्मद उमर ओके
So in our class, aldehydes and ketones is going on.
ओके
Also,
बताइए
so the portions you'll teach in extra class, you won't teach in tuition again.
I will teach in tuitions. I mean extra classes no relationship with these classes.
अच्छा, okay, sir.
हाँ नहीं मतलब आपके लिए रिडंडेंट हो जाता ना अगर हम आपके एक्स्ट्रा क्लास में भी कोऑर्डिनेशन कंपाउंड पढ़ा रहे हैं और यहाँ पे भी अगर कोऑर्डिनेशन कंपाउंड पढ़ा रहे हैं तो right?
Yes, sir.
And that is why I'm choosing two different chapters. एक्स्ट्रा क्लास में सारे बच्चे समय नहीं आएंगे ना, सारे बच्चे अगर एक्स्ट्रा क्लास में आते हैं तब तो फिर कोई बात नहीं है ना, तो उसको पढ़ाने की जरूरत नहीं, आपको खुद नहीं अटेंड कीजिएगा एक बार पढ़ने के बाद, राइट? लाइक फॉर एग्जांपल यू, अगर हमने कोऑर्डिनेशन कंपाउंड खत्म करा दिया, then obviously you will not be attending the coordination compounds in this class, right? Regular classes. Asta?
Yes, sir.
Okay, right? Kohlrausch law. Of independent migration. Also sometimes known as just the law of independent migration. It's a very simple law. It states that the molar conductivity that you are getting from NaCl, okay? Just a second. The molar conductivity that you are getting from NaCl is due to the molar conductivity of Na plus and the molar conductivity of Cl negative. If I add up the molar conductivities of Na plus and Cl negative, then I will get the molar conductance of NaCl. That's the simple law. Okay, I hope you have written the heading. Please write it down fast. What is happening? Just a second, let me reshare. Eraser is not working. Why the eraser is not working, guys? Okay, please write the molar conductance of an electrolyte at infinite dilution is equal to the sum of molar conductance of its contributing ions at infinite dilution. It says lambda naught m is equal to lambda naught of cation plus the lambda naught of anions. For example, if I have lambda naught NaCl, this will be equal to the lambda naught of Na plus and lambda naught of Cl negative. Similarly, if I have lambda naught of KCl, this will be equal to what? Tell me, guys. Lambda naught of
A plus MCl lambda
A
naught of K
plus
minus.
lambda naught of Cl minus.
yeah, correct. Lambda naught of K plus plus the lambda naught of Cl negative. Now, if I have something like lambda naught of MgCl2, now in this case, now MgCl2 means what? It has Mg
Mg2
and 2
plus.
plus. Mg2 plus and then
Cl
We
minus.
have, no, there are two Cl negatives, right? So you'll have lambda naught of Cl negative plus the lambda naught of Cl negative. And we can write this as lambda naught of Mg2 plus 2 into lambda naught of Cl negative. Is this clear with everyone? Yes or no? Please tell me. Contributing ions. What are the ions present in MgCl2? The MgCl2 will dissociate into Mg2 plus and chlorine negative and another chlorine negative. And by using maths, in order to save time and space, we write it 2Cl negative. Okay, we write it 2Cl negative. So this will be also the molar conductance of MgCl2. Contributing ions are what? One Mg2 plus and there are two chloride ions. Is this clear with everyone? Yes or no? Please tell me.
Yes, sir.
Okay. Now, similarly for AlCl3, this will be lambda naught of Al3 plus lambda naught, 3 lambda naught of Cl negative because you have 3 chloride ions. Right, next lambda naught of CH3COOH will be equal to lambda naught of CH3COO negative plus the lambda naught of H positive. Then guys, yes, no, please tell me.
Done, sir.
Right, next. Write a remark. In general, for an electrolyte, lambda naught M is equal to N plus lambda naught of cations plus N negative multiplied by lambda naught of anions. What is N plus? It is the number of cation after dissociation. Number of cation after dissociation, and N negative, number of anion after dissociation. Then guys, आगे बढ़े. Right,
Yes.
next applications. Okay, so the first application for Kohlrausch law will be to determine the molar conductance of weak electrolyte at infinite dilution. Number one, to determine lambda naught m of weak electrolytes. है ना, याद है आप लोगों को कि ग्राफ से इसको नहीं निकाला जा सकता. That's why we have this formula, electrolytes. Okay, always remember the framework of whenever you want a quantity of something, you want to measure something, there are two ways of getting that particular measurement. Okay, you can either measure it using a tool, or you can calculate it using a formula. In this case, lambda naught m of strong electrolyte, it can be calculated using what? Conductivity. If you can measure the conductivity and plot the graph, you can get the lambda naught m for strong electrolyte. For weak electrolytes, you have to calculate using Kohlrausch law of independent migration. Okay, always remember this framework. There are things you can measure and there are things you can calculate. Right, next. This can be done because at infinite dilution, weak electrolytes behaves as strong electrolyte. Okay, right. First example, lambda naught of CS3 COONA is given as X Siemens centimeter square mole inverse. Lambda naught of NaCl is Y Siemens centimeter square mole inverse. Okay, lambda naught of HCl is given as Z Siemens centimeter square mole inverse. And they are asking, so all of these are strong electrolytes. They're asking find lambda naught m of acetic acid CS3COOH. It is a weak electrolyte. Now, for these type of questions, what you need to do is you need to first of all understand what are the ions that we are going to get when we are going to dissociate all of these given data. So this is the given data. So first is CS3 COONA. From this I am going to get CS3 COO negative and Na positive. Then you have NaCl. NaCl on dissociation is going to give me Na plus and Cl negative. Then we have HCl. It is going to give me H plus and Cl negative. Okay, so these are what, and what are the lambda naughts for these? This is X, this is Y, and this is Z. So this is the given data, and then we have the target. What is my target? Target is the weak electrolyte that we have to find the lambda naught m of. So we have CS3COOH. This is going to dissociate into CS3, COO negative, and H positive, right? And H positive. Now, for this, you tell me, where do you see the CS3COO negative? In X, Y, or Z? Where do you see CS3COO negative in X, Y, or Z? Tell me, guys.
X.
X, okay. Where do you see the H plus?
Z.
Z, right? Now, for this, that means the lambda naught will be plus X plus Z, and this will be minus Y, because we are not seeing Y in this particular equation. Now I will tell you why this is going to work. When I write plus X, what I mean is I am going to add these two, CS3 COO negative plus Na positive, right? The lambda naught of CS3, COO negative and Na positive. Then I am going to add the Z also. What is the Z? It is H plus Cl negative. And then I'm going to subtract the Y, that means minus Na plus and Cl negative. Now, if you want to cut things, Na plus and minus Na plus is going to cancel each other out, plus Cl negative and minus, my bad, and minus Cl negative will be cancelling out. What we are going to get? We are going to get CS3 COO negative plus H positive, right? This was our target, and we have got the target using all the given data. Can all of you see this? Yes or no? Please tell me. Can all of you see this? You have to first of all see what are the products of dissociation of the target, and then you have to look in the given data where it is falling, in which of the electrolyte it is falling, the dissociated ions, and if it is present, then it is positive. If it is not present, then you have to take the negative of that particular thing. All of you got this? Yes or no? Guys, no. Astha, Khalid, Nabil.
Yes, sir.
Yes, sir.
Yes,
Got
sir.
it.
Got it, na? तो हाँ ना कुछ तो बोलिए भाई. So we can write lambda naught of CS3 COOH will be equal to lambda naught of CS3 COONA plus lambda naught of HCl minus the lambda naught of NaCl, right? This is going to give you X plus Y, sorry, X plus Z minus Y. And this will also be in Siemens centimeter square mole inverse. Okay, Siemens centimeter square mole inverse. Write this down. Let me know once you're done. Is everyone done? No, it's writing. Write it fast, guys. चलिए guys, let's move on. Write the next question. Okay, ये वाला आप लोग कीजिएगा. ठीक है? It's very easy. Write the question. You have been given the lambda naught of NH4Cl. It is, अच्छा यहाँ पे X, Y, Z करके कर रहे हैं because I don't want you to waste time on calculation. I'm just focusing on chemistry right now. Okay, so you will just get some numbers here, nothing else. X Siemens centimeter square mole inverse lambda naught of NaOH is Y Siemens centimeter square mole inverse and lambda naught of NaCl is equal to Z Siemens centimeter square and mole inverse. They're asking you to find lambda naught of NH4OH. चलिए प्लीज कीजिए इसको. See, you even don't need to write all of these things, all of the given data. I'm just asking how your mind should process. Okay, so this should be in your head or in your copy at least. If it is not there in your head, then you have to write it down. Okay, Same thing goes for the target reaction also, the target dissociation also. If you can see how what are the ions that are going to get formed, then you don't have to write it. But if you don't know, then you have to write it so that you can understand what is going to happen. Okay. So if you're not very confident, then please write it. If you're confident, then you don't need to write all of these dissociation reactions. Okay. You just need to get what are the positives and the negatives. So write this down. Send the answer on WhatsApp. Message me on Zoom chat if you're stuck. Nabil Ahmed, it is very similar to the last one, no? Minashi, wait a second. Let me check your answer. Yes, Minashi, very good, correct. Salman. Very good, Salman, correct. So, Nabil, at least can you do till here? Can you write all the dissociation reactions till here? And then you will understand on your own. Hopefully. Asta, that is correct. Very good. Yes, Khalid, correct. Guys, see NH4OH. It will dissociate into NH4 positive and OH negative. Now tell me, NH4 positive is in which electrolyte? NH4Cl and NaOH, NaCl. किसमें है NH4 plus? NH4 plus is in which electrolyte? X, Y or Z? जल्दी बताइए. Hello, am I audible, guys?
Yes,
आवाज
sir.
आ रही? हाँ जी, बताइए. NH4 positive is in which electrolyte? X, Y or Z?
X, sir.
X. OH negative is in
Y.
है ना, तो प्लस x है ना, y को भी हम लोग प्लस में लेंगे एंड NaCl it is not present, that is it will be minus z. ठीक है, as you can see, देखिए हम आपको बताते हैं फिर से. If I am taking x or rather plus x, then what is extra here? I need NH4 positive, but here we have NH4 positive and what else is present here? NH4 positive and what else is present here? और ये जल्दी बताइए guys. NH4Cl में NH4Cl will dissociate into NH4 positive and yes, Nabil Ahmed, tell me.
Sir.
नहीं पता. अरे NH4Cl किस किस में डिसोसिएट होगा? NH4Cl will dissociate into
NH4 plus and Cl minus.
Cl minus. And from both of these electrolyte, what do I need? I need only
NH4 plus.
NH4 plus. Cl negative is extra. और यहाँ NaOH हमको क्या चाहिए? OH negative चाहिए. Na plus है extra. That is why I'm going to delete this Na plus and Cl negative using this lambda naught. Okay. So X plus Y minus Z. Got it? Lambda naught of
Sir.
NH4 lambda naught of NH4 OH is equal to X plus Y minus Z Siemens centimeter square mole inverse. Right, next. Lambda naught of NH4Cl is equal to X Siemens centimeter square mole inverse. Lambda naught of BaOH whole twice equal to Y Siemens centimeter square mole inverse. Lambda naught of BaCl2 is equal to Z Siemens centimeter square mole inverse. They're asking you to find lambda naught of NH4OH. ठीक है, अब यहाँ पे देखिए आप अगेन NH4OH NH4 positive plus OH negative. ठीक है, यहाँ पे ध्यान से देखिएगा. Write the question down and then leave your pen aside. Okay. Now obviously you can see that it is plus X because I will get NH4 plus from the X Siemens centimeter square mole inverse which correspond to NH4Cl. Where will I get OH negative from? Tell me guys, where will I get the OH negative from? जल्दी बताइए, OH negative कहाँ से मिलेगा? OH negative कहाँ से मिलेगा? Y से मिलेगा, but will we get one OH negative or two OH negative if I take Y?
2, sir.
2 मिलेगा, right? And that is why what I need to do is I need to take Y by 2. If I take Y by 2, then I will get only one OH2 negative. Can all of you see that? Yes or no? Please tell me. Right?
Yes, sir.
Y by 2. Now, what do I have extra? I have an extra Cl negative and I have half Ba positive, right? Half Ba2 plus. अब यहाँ पे क्या करेंगे? Plus ये 2 भी Z की तरह दिख रहा है. Change this. Now this will be minus. I can remove the Cl negative from Z by 2. है ना, Z by 2 आपको क्या देगा? Z by 2 will give you half of Ba2 positive and 1 Cl negative, and that's what I need to remove. Got it, guys? Yes or no? Please tell me.
Yes, sir.
So this will be lambda naught of NH4OH. Same in centimeter square per mole. इसके अलावा कोई और सवाल आपके पास नहीं आएगा. Okay. This can be the most tricky question they can ask you. लेकिन प्लीज अंधों की
Sir, can you please explain it again? I'm yet confused why 1 by 2.
Sure, no problem. Where did I get NH4 positive from? X, Y, or Z? Salman, keep your mic on, Salman.
H positive from X.
X. Okay, and what do I need next? OH negative, right?
Yeah, OH negative from Y.
Where will Y?
But,
But
two.
will I get only one OH negative or two OH negative if I
Two.
take Y? So in order to take only one, I divide it by 2.
Yeah. Okay.
Got it? Okay.
Yeah. Okay.
One more thing, देखिए, in your case, you are going to get simple cases. ठीक है, जिसमें you will be having 2 electrolytes which will be in positive, 1 electrolyte which will be in negative. ठीक है, and there will be only 3 given to you. But maybe to confuse you, they can give you 4 or 5 also. Now, if they are going to give you 4 or 5 electrolytes and their molar conductance at infinite dilution, then you need to really see which of the electrolyte is going to give me the target dissociated ion and which of them it is not going to give me. And then you also need to see what are the extra dissociated ions that I am going to get. For example, if I take X, I'm going to get Cl negative, and how to eliminate those ions. Okay, ऐसे अंधों की तरह जो मिल रहा है उसको पॉजिटिव और जो नहीं मिल रहा है उसको नेगेटिव मत कीजिएगा. मोस्ट ऑफ द टाइम्स इस तरह से भी करने से आपका काम चल जाएगा, लेकिन if you have more than 3, then just pause for a bit and rethink how to do this. Okay, but in generalized case, in the most of the cases that you are going to get, you will be having ions that are present that will be in positive, ions not present, just take it negative. अगर सब कुछ भूल जाए तो बस इसको याद रखिएगा. चलिए, right next, to determine degree of dissociation. Second application. To determine degree of dissociation of weak electrolytes. Now, all of you please listen. All of you please listen. Don't write, okay? Don't write. We are taking a weak electrolyte, that is AB. Now, and we have taken some concentration C at some concentration C. AB is going to give me A plus and B negative. Okay, it is giving me here, let us say 10 A positive and 10 B negative, right? 10 moles of each. Then can I say, if this is weak electrolyte, please remember A and AP is what? Weak electrolyte. Can I say that I have just taken 10 moles of AB? Yes or no? Tell me if it is weak electrolyte. ऐसे मान लीजिए अगर आप NaCl को लीजिएगा, if you take 2 moles of NaCl, okay, if you take 2 moles of NaCl, you are going to get what? 2 Na positive and 2 moles of Cl negative. Okay, because this is what? It is a strong electrolyte. But in the case of weak electrolyte, can I say that if I'm getting 10 A positive and 10 B negative, can I say that I have taken only 10 moles of AB? Yes or no? What do you guys think? Can I say that I had taken 10 moles of AB? Yes or no? Weak electrolyte बताइए क्या होता है? Completely dissociated या partially dissociated? Weak electrolyte is completely dissociated or partially dissociated?
Partially dissociated.
Partially dissociated. That means whatever A positive I am seeing here, whatever B negative I am seeing here, it is not the complete picture of AB. It is just the partial picture of AB, right? That means the moles of AB that I have taken will be obviously greater than 10, right? Because out of, let us suppose, some moles, 10 has dissociated. There are some remaining moles of AB which is undissociated because weak electrolytes are partially dissociated. That means I cannot see how much mole of AB I have taken. Why? Because this is partially dissociated. And the lambda M, that is the molar conductance that I will get at this particular point, will be lambda M at C concentration. Now I will dilute it infinitely. At infinite, please don't write, listen. At infinite dilution. Now at infinite dilution, weak electrolyte, they behave as strong electrolyte. That is why I get AB, and here I will get A plus, and here I will get B negative. Let's suppose we are getting here 30 A plus and 30 B negative. That means we have taken how much? 30 AB. I have taken how much? I have taken 30 AB. And this picture is about complete dissociation. Complete dissociation. And the lambda, the molar conductivity that I will be getting here is lambda naught M. Okay, lambda naught M. Now the degree of dissociation, what is the degree of dissociation? Degree of dissociation tells me about how much of an electrolyte is going to dissociate. How much of an electrolyte is going to dissociate. So I took AB, some concentration of AB, right? I took some concentration of AB and it gave me 10 moles of A plus and B negative, right? Then I diluted it furthermore. I'm not changing the number of moles, okay? Please remember that the number of moles of AB is just the same. I'm just adding more and more and more and more water. What I saw that after we are getting 30 moles of A plus and 30 moles of B negative, the conductivity is not increasing. That means this is the limiting molar conductivity, and these are the number of ions that has been dissociated. And since it is completely dissociated at infinite dilution, we can confidently say that I have 30 moles of AB on the starting. So this was also what? 30. At concentration C, at some concentration, because it is partially dissociating, I am getting 10 plus and 10A plus and 10B negative. Now, what is the alpha here? The alpha is equal to, the alpha is the degree of dissociation. Degree of dissociation means how much is dissociating out of the complete ions. So how much is dissociating? 10 is dissociating out of 30. Can all of you see that? Yes or no? Please tell me.
Yes, sir.
Now this 10 will correspond, and I can see the 10 and it will correspond to lambda MC. I'm not seeing the value of lambda MC will be 10, but what I am saying that this 10 moles of A plus and 10 moles of B negative will determine the lambda MC, and this 30, it will determine the lambda naught M. Can all of you see that? Yes or no? Please tell me. Can all of you see that? If it is, see, when it is partially dissociated, that is the molar conductivity at some concentration. When it is completely dissociated, it is the molar conductivity at infinite dilution, right? That means this molar conductivity will be due to this 10-10. This molar conductivity will be due to this 30 ions. Can all of you see that? Yes or no? Now tell me.
Yes, sir.
And that is why the alpha is given as, please write, degree of dissociation alpha is lambda M at some concentration C divided by lambda M at infinite dilution or zero concentration. And also remember, what is this lambda MC? What is the formula? Formula for lambda MC is kappa into 1000 divided by molarity. शायद आप लोगों को याद होना चाहिए, लास्ट क्लास में हम लोगों ने पढ़ा था इसको. Okay, write this down.
10, sir.
Okay. Right, next. To determine the dissociation constant of weak electrolyte. Third application. To determine the dissociation constant of weak electrolyte. Okay. From equilibrium chapter, you must remember. If you don't remember, then just mug up this formula now. Dissociation constant capital K is equal to C into alpha square upon 1 minus alpha. What is alpha? Alpha is the degree of dissociation of a weak electrolyte. Okay, so you have to remember this formula. And previously we saw that alpha is equal to what? It is equal to lambda m at a particular concentration divided by lambda m at infinite dilution. So now this dissociation constant K will be equal to C into lambda mc upon lambda m naught square divided by 1 minus lambda mc upon lambda naught m. चलिए लिख लिया आप लोगों ने ये सोनो प्लीज मी. अरे लिख लिया आप लोगों ने या नहीं? नहीं लिखा अभी तक. There are 3 topics, majorly it is 2 topics only that you need to read from NCERT. First is battery and its type. Second is corrosion. Corrosion and how to you can say avoid it. Okay, so there will be some reaction, you need to remember those. Thirdly is a very small section on hydrogen economy. Okay, so these are small topics that you need to read from NCERT. Very rarely there are questions from these 3 topics, but if you just read the NCERT and do the NCERT question, you will be okay. Okay, and in the next class, I will start with aldehyde ketones and carboxylic acid. Aldehydes ketones and carboxylic acid. Okay, and also there will be, see, we had done some part of aldehyde ketones, right? Carbonyl compounds. We have done 2 classes, right? ये दिख रहा है आप लोगों को, है ना? तो IUPAC नॉमेनक्लेचर का टेस्ट लेंगे हम, एंड व्हाट एल्स? Okay, I will take this test on 2 topics: IUPAC nomenclature, common names, IUPAC nomenclature, and method of preparation from alcohol by oxidation. ठीक है, इसको लिख लीजिए. Next class, that is on Tuesday, 22nd November, Tuesday. Test on common name, IUPAC name, and method of preparation of aldehyde, unketones using alcohol by oxidation. ठीक है? Test will be of 10 marks and half hour. It will be subjective type, no MCQ.